Let's do trapping rainwater next. Given n non-negative integers representing an elevation map where the width of each bar is 1, compute how much water it can trap after raining. Boy, that is a confusing wording. Let's just look at the picture. So this is what they want. They want, like, if you've got some different rock heights on a 2D plane, which parts of it make like a little bowl shape where you can fit water. So the overall approach, it's going to be a two-pointer algorithm. So if you've done, say, like 3-sum, with the inner loop as two-pointer, it's basically starting one pointer at the left and one at the right, and stepping along and doing some kind of logic in the meantime, which means that the runtime is going to be linear with, I think we can get away with constant space on this, since we just need like some integers, so like the positioning, checking the heights in the array, and yeah, just like an integer to accumulate our output, and that's pretty much it. So 2 pointers is usually linear. Let's start writing it out. Okay, so we're gonna need some values. We're gonna need so return ret for return. Start it with 0, and we're gonna need. I'm gonna use some iterators for this. So we've got vector, integer, iterator. We're going to say the low one starts out as height begin. And we're going to have a high one starting out at the end. And then, so we wanted to look at the actual value, not one past the end. What else do we need? Let's write out the main loop, see what we need from there. So we've got while. And then we're going to exit when the two meet in the middle. So we've got low is not equal to high. Yeah, so the general gist of it is we're going to, oh yeah, so I remember what we need next. We need to track like the max we've seen so far for each pointer. So max low is 0, and then max high is also 0. All right, so let me talk about what each of these things are going to do. So we need to know for each of the two left and the right pointers, we're using two different ones so that they never go past the very tippity top of the mountain, because you're never going to hold water there. So just to make sure that you know that, like, okay, if you've got some mountain and you've seen stuff to one side of a peak, if you can trap water in like a dip versus you don't want to, like, say you've got water way up here going out to that end. So that's kind of how it's handled. Yeah, so like say if you're going from left to right, you know that like the highest, if you've seen a height higher than what you're currently at, that means you can add water in the amount of the difference between those two. So like here, you've seen a 1, and then it drops down to 0 again. So you can add 1 unit of water. And then up here, so you know that the highest you've seen so far is actually now 2. So the rock height here is 1. So the difference between those, you can add water. And then you've still got this max of 2 by the time you get here, but the height is now 2. Sorry, the current height is 0, max you've seen so far is 2, so it means you can add 2 units of water here. And as you keep scanning, you'll add another unit, and then you'll stop here. And same for the right pointer. It's going to go, since it's just kind of strictly increasing all the way until here, you don't add any water until this point, and then after that it's more increasing. So that's kind of how it goes. So let's set our max value. So max low is equal to the max of itself, or the value in the pointer there. So max low, low. The value in low, and then same for the high. Max high equals max of itself. Yeah, pretty much. And then we're just going to increment whichever one is smaller. So whichever one we know has not reached the top of the mountain yet. Yeah, pretty much. So like by the time the left pointer is going to get over here, and then yeah, you just never want one of them to pass the top of the mountain. So we'll just always change the one where the highest it's seen so far is lower. So if max low, and then we can break ties by going left. It doesn't really matter. Max high. We're going to add to our output. So rit plus equals max low minus the value in the low pointer. That's technically an iterator. And then we can increment so low. Yeah. And then else. Same for the the right side. And the high iterator. And then decrement the high pointer. And then we want to return our output at the very end, and then that's pretty much it. All right, so let's talk about runtime and then do an example. And then maybe some intuition about how we know we can use a two-pointer approach here. Yeah, when I first started trying out this problem, I was thinking if I could do something with dynamic programming realistically, but yeah, it's definitely two-pointer. So if you, best I can say is compare it to threesome. Yeah, it mainly comes down to knowing that you want to know where the peak is. That's kind of relevant. The current peak versus other local peaks, or the global peak versus local peaks. And then water would fit in between local peaks of equal height. So for example, if this height here were 1, that would kill all of this. Yeah, pretty much. Anyway, so it's linear time because it's going, the two pointers meet in the middle, O of n time, and constant space. Yeah, let's do an example. I'm gonna do, we'll just do the example with the picture. That's fine. Copy this over here, and then we've got our high max high, max low, and we've got our return value. So initialize these to 0, and let's begin. So setting these, we set our iterators so that we've got these beginning ones. I'm just gonna erase as I go instead of messing with like typing out things. You know, I take that back. I'm gonna use asterisk. All right. So the max that each has seen so far now. So this is gonna become. I'm gonna swap these. I think it'd be easier to keep it straight if they were swapped. All right, so 0 versus 1. And then this is lower, so we're gonna look at the left side. We've got 0 minus 0. That's not gonna change anything. Let's just increment it and move on. Okay, and then this max is gonna go to 1 now, but it's a tie, so we're still gonna look at the left side. So we've got 1 minus 1. We're going to add 0 to our output and move our iterator. Now we can actually add some water. So we've got, first the maxes, 1 versus 0, 1 versus 1. Our maxes don't change. But now we've got this 1 minus 0. We can actually add 1 to our output. And then we move the pointer. We've still, well, okay, so now we're going to move this max up to 2 because of this. This one's not going to change. And so now we're going to actually move the right pointer a little bit because it's smaller. So we've got 1 minus 1. So we're going to add 0 to our output and move this along. All right, update our maxes. This is going to go to 2 now because of this. But this one's not going to change. So now we're going to look at the left side because there's a tie. But we've got 2 minus 2, so we're adding 0 to our output and then moving along. All right, so now still a tie, but we're going to add 1 to our output. Add 1 because of this guy. And move it along. Still a tie, so now we're going to add 2 minus 0 to our output. So we're up to 4. And for reference, this is where we're at right there. All right, and then move it along. Move it along. All right, we've still got a tie. We're going to add 1 to our output because now it's 2 minus 1, so now we're up to 5. Goodness, we are just trucking along on that left side. Although now the left side has reached the global peak. It's right there. So in this next iteration, we're going to update our maxes. That's going to 3, 3, and now the right side is lower. So we've got 2 minus 2, so we're going to add 0 to our output and move the right pointer along. Right side is still smaller, so we're going to add 2 minus 1. So that's our final one. That's it, right there. We're going to add that, and the next should just be incrementing pointers, or decrementing, moving them along. So we've got this. The maxes don't change, so we're going to look at the right side. 2 minus 2, so we're going to add 0 to our output. Move it along. And now we see that our 2 pointers have met in the middle, right there at that 3, at that global peak. And we've got 6 water, and so then we're going to break and return. Yeah, let's give it a run for syntax. Cool. And submit. And mark it off, trapping rainwater. Thanks, guys.